Okay, welcome all. So today we are in another lesson of part 2, the doubly reinforced beam. In this numerical we will see how to design a doubly reinforced beam. So let's check the numerical. See here, given as design a RC beam of effective span 6 meter, means L is equal to 6 meter. The span is 6 meter. To carry a superimposed load of 25 kilonewton meter. Superimposed load means the live load is given. Okay, so the live load is given, we have to calculate the dead load, okay, or the self weight. The beam size is restricted to 250 into 500. It also given in the image also, 250 into 500. Use M20 and FE415. Okay, so we have to, FCK is 20 and Fy is equal to 415. Okay, so let's start. So as it is, we have to design the beam. As we have to design the beam, we will take it as a balanced section. Okay, balanced section. What is the meaning of balanced section? XU is equal to XU limiting. Okay, so in every calculation we will take the XU limiting value. So first we will calculate the XU limiting. So XU limiting is equal to K into D. The value of K for FE415 is 0.46. 0.46 into D. See, D is 500. So 500 minus the effective cover 50. 500 minus 50. So it's coming to 216 mm. Okay. See here, the live load is given as 25 kilonewton per meter. Okay, so we have to calculate the self weight. How we will calculate the self weight? Self weight is equal to the dimension of the beam, 500 and 250. You have to write it in meter. Okay, 0.25 into 0.5 into the unit weight of RCC is 25. Okay, so you can get these values in IS 875 part 1. Okay, so the unit weight of brick, the unit weight of RCC, the unit weight of cement, you can get it in IS 875 part 1. So the value is coming to 125 kilonewton meter. Okay, so by adding these two, the total weight is coming to 25 plus 3.125. It's summing up to 28.125 kilonewton per meter. So now we have to calculate the factored load. Okay, as we take a factor of safety, so we will calculate now the factored load. The factored load is just 1.5 times the load coming. Okay, 28.125 is equal to 42.18 kilonewton meter. Now for a simply supported beam, we know that the bending moment design is equal to WL square by 8. Okay, so we are putting the values here. W we have calculated as, this is W.18 into L square is a 6 square, the span is given as 6, and divided by 8. The value is coming as 189.84 kilonewton meter. Okay, so the bending moment design is coming here. We also know the formula of mu limiting, moment limiting. Okay, moment or bending moment limiting, you can write it as anything, or bending moment limiting is as QBD square, QBD square, and Q for FE 415, Q for FE 415 is as 0.138 FCK. Okay, this is the value of the Q, and B is given as 250, and D is given as 500. So 500 is given, we have to write it minus cover 450. Okay, 450 square. So the value is coming to 139. FCK is 20, you will replace it by 20, and you will convert it by dividing 10 to the power 6. Okay, just divide this value, the value coming here, you divide it by 10 to the power 6, it will convert it to kilonewton meter. Okay, the value is coming as 139.725 kilonewton meter. Okay, now we will just calculate bending moment extra. Means, see here, the bending moment limiting value is 139.725, but your bending moment coming actually is 189. So some extra part is coming. For that we have to give extra rebar. So we will see that what is the extra part. So we will just minus subtract bending moment design minus bending moment limiting. Okay, 189.84 minus 139.725, that's coming to 50.12 kilonewton meter. Okay, so this is coming. Now we have to calculate the area of steel. Mainly what design means, we have to calculate the area of steel. Okay, so now we will go to the calculation. See, as extra moment is coming, what we have to calculate? We have to calculate AST1, AST2 and ASC. Okay, this we have previously seen in singly also. This we give it for bending moment limiting. Okay, from doubly these values have started, so we give it for bending moment extra. Okay, and this also we give it for bending moment extra. So see, the formula will be accordingly. For AST1, the previous formula was the same, here also will be the same only. Mu limiting divided by 0.87 Fy into the lever arm D minus 0.42 XU. XU means here it will be XU limiting only. Okay, so see, the mu limiting value has come to 139.725 divided by 0.87. Fy is 415 into D is 450 minus 0.42 into XU. XU is, see, XU is 216. Okay, 216. See here, all the values are in mm. 415. Okay, 216. So we have to this value is in kilonewton meter. Check here, this value is in kilonewton meter, so we have to just multiply it by 10 to the power 6. Okay, so the value will be coming in mm square. So the value is 1077 mm square. So this is AST1. So now we will calculate AST2. AST2. See, the AST2 is calculated for bending moment extra. So we will write here bending moment extra divided by 0.87. Just the lever arm will change here. It will be D minus DC. Okay, as you have seen that in doubly reinforced there are two lever arm. So for bending moment extra, the lever arm is D minus DC. Okay, so now we will calculate it. Bending moment extra is 50.12 divided by 0.87 into 415 into D is 450 minus DC is 50. So the value will be coming to 347 mm square. So AST will be AST1 plus AST2 is equal to 1425 mm square. So this is the answer of AST, the bottom part steel. Now we will calculate the ASC, area of steel in the compression zone. ASC. So the formula is bending moment extra. So this is also coming for the extra part only. So the bending moment extra okay. So now the formula here is FSC minus 0.45 FCK into D minus DC. Here comes the twist. So FSC we don't know. Okay, we have just a given chart. What is the given chart? So we'll write it here. First we calculate the value of strain. Okay, the strain we calculate it, then we will see the given chart. So the strain formula is 0.0035 multiply with XU minus DC divided by XU. Here XU is XU limiting, so the value is 0.0035 into the XU is 216 DC is minus 50 divided by XU 216. So the value is coming to 0.002689. Okay, so this is the strain value. Okay, so we will now see the given data. Given the chart is, here is the see, here is the strain value. Here is the strain value, that is 0.00241, and here is given as 0.00276. Okay, here is the given value FSC, that is 342.8 and 351.8. The value we have got is this strain. We will write it here. 0.002689. For this we have to calculate this one. Okay, so now we will do the interpolation. Okay, we will do the interpolation. So how we will do it? Let's see. We are telling it as x. So x is equal to 3, this value 342.8 plus this minus this 0. Wait a minute. I will also check once. Yeah, this minus this, so this is 0.00241. Okay, minus 0.00276 divided by 351.8 minus 342.8 and multiply it with 0.002689 minus 0.00241. Okay, so the epsilon SC is coming to 342.8. Okay, so now again we will calculate it from there. Okay, we will start from here. Bending moment extra, see, it's coming to 50.12 50.12 into 10 to the power 6 divided by FSC is coming to 342.8 bracket 342.8 minus 0.45. FCK is 20 and it's coming to 450 minus 50. So if you calculate it, the value will be coming to, wait, I have to calculate it. 3 bracket 3 342.8 minus bracket 0.45 into 20 bracket. So this bottom part is totally coming to 133520. Okay, 50.2 into 10 6 divided by 133. So it's coming to 375.37 mm square. Okay, so we have got the values. See, this is one answer, this is ASC. Okay, so this is one answer, and AST, this is one answer. Okay, so we are ending up the lecture here. Thank you. We will come up with another numericals of another chapter.